Welcome to this explainer. Today we're taking a massive deep dive into the high-stakes, highly technical world of sourcing fuel tanker trucks from China. Look, if you're managing procurement for a global energy fleet, you already know this isn't like buying office supplies. Not even close. You are sourcing a mobile pressure vessel literally designed to carry tens of thousands of liters of highly volatile, heavily regulated liquid. So we're going to break down exactly how seasoned professionals navigate this incredibly complex supply chain to secure top-tier equipment.
It really all comes down to this single, crucial question. What separates a highly profitable, efficient fleet from a catastrophic logistical liability? Because transporting fuel is inherently dangerous, and global standards are absolutely unforgiving. A single failure on the highway? Well, it doesn't just mean a delayed delivery. We're talking about a potential environmental disaster, massive fines, and quite frankly, a complete shutdown of operations.
There's a universal truth in this industry. Procuring high-capacity fuel transportation equipment is a high-stakes engineering decision. I want you to really focus on that word, engineering. Amateur buyers, they tend to look straight at the price tag, just hunting for the lowest quote. But today, we're diving deep below the surface into the engineering reality. To make a smart procurement choice, you absolutely have to understand the metallurgy, the safety systems, and the strict compliance requirements that actually dictate true long-term value.
Okay, let's dive into this. Here is our roadmap for the explainer today. We'll start by looking beyond the price tag, then move into choosing the right material, essential safety loading systems, verifying true manufacturing capability, navigating compliance and customization, and finally, RFQs and procurement logistics.
All right, let's kick things off with Section 1, Beyond the Price Tag.
We have to address the elephant in the room regarding the Chinese manufacturing landscape, because it has shifted dramatically in recent years. The specialized vehicle sector has evolved way beyond simple assembly. It's now a hub of really sophisticated custom engineering. But that means the onus is entirely on you, the buyer, to vet these suppliers thoroughly. You need to evaluate them on their technical depth, their manufacturing tolerances, and their proven ability to meet rigorous regional compliance standards, things like ADR in Europe, DOT in North America, or ASME for high-pressure vessels. Remember, your goal isn't just to buy a truck, it's to secure a rock-solid long-term asset.
Which brings us nicely to Section 2, Choosing the Right Material. The metallurgy of the tank is the literal foundation of your investment. Pick the wrong metal for your specific fuel profile, and you're looking at premature corrosion or, worse, structural failure under hydrostatic pressure. Let's break down the three primary options reputable suppliers offer. Carbon steel, typically 5 to 6 millimeters thick, is your budget-sensitive standard for domestic short hauls, though keep in mind it often requires internal anti-corrosion coatings. Then you have stainless steel. That's highly specialized, mostly reserved for aviation fuel or corrosive chemicals where you need absolute zero contamination. But the real game changer is aluminum alloy, specifically grades like 5083 or 5454. By dropping the tank weight by up to 40% compared to steel, an aluminum body lets you drastically increase your payload to weight ratio. We are talking about hauling up to 30% more fuel per trip while actually reducing the prime mover's fuel consumption. That is a massive direct boost to your profit margins for long-haul operations.
Now, what's really interesting about this 15 to 20-year time frame is why it happens. Because aluminum is naturally corrosion resistant, it completely eliminates the need for any of those internal coatings. With just standard, proper maintenance, an aluminum tank is going to give you a 15 to 20-year operational lifespan. Compare that to carbon steel, which generally taps out at about 10 to 12 years. So suddenly that initial price difference up front doesn't seem so large when you factor in almost double the working life, right?
Moving right along to Section 3, Essential Safety Loading Systems.
Global safety standards are moving incredibly fast, and the old methods of climbing up and top-loading a tanker, those are becoming totally obsolete and, frankly, illegal in a lot of jurisdictions. Today, a bottom-loading system is an absolute non-negotiable standard for any modern compliant fuel exporter. By definition, this is a highly sophisticated closed-loop integration. It minimizes dangerous vapor emissions and is absolutely critical for preventing static-induced fires during the high-speed transfer of fuel.
Let's break down the specific components you literally must demand in a technical proposal. First up, pneumatic foot valves. These sit at the very bottom of the tank. If the truck is in a collision and the external pipes are completely ripped away, this valve remains hermetically sealed inside the tank to prevent a catastrophic spill. They are absolute lifesavers. You also need a vapor recovery system for environmental compliance and overfill prevention sensors. These are optical or thermistor sensors that automatically cut the fuel flow the exact millisecond the tank hits 95% capacity. Finally, API standard adapters, usually 3 or 4 inches, these guarantee your truck will actually be able to connect to international terminal loading racks.
Let's shift our focus down to the factory floor for Section 4, verifying true manufacturing capability.
When you're operating overseas, it can be incredibly difficult to distinguish between a middleman trader working out of a tiny office and the true Tier 1 OEM manufacturer, and this brilliantly illustrates the difference. Manual welding is prone to human error, inconsistencies, and shallow penetration. A true OEM, on the other hand, will use automatic submerged arc welding, or SAW. This technology ensures incredibly deep penetration and a flawless, consistent weld bead. Why does this matter so much? Well, imagine a tanker truck carrying 40,000 liters of diesel. During emergency braking, it experiences massive violent sloshing forces inside the tank. The structural integrity of those main weld seams is literally all that stands between a safe stop and a fully ruptured tank.
To prove that integrity, you can never just take a supplier's word for it. Demand a 100% radiographic testing report. That's literally an X-ray of the main weld seams to detect any invisible internal defects. Require hydrostatic pressure test certificates. And for surface treatment, ensure they specify SA 2.5 grade sandblasting, followed up by a multi-layer epoxy primer and a polyurethane top coat. Professional buyers actually routinely hire third-party inspection firms like SGS or Bureau Veritas to verify these exact specs before the truck ever leaves the Chinese port.
All right, on to Section 5, navigating compliance and customization.
The absolute worst-case scenario in international procurement is successfully building and shipping a beautiful fleet of trucks only to have them permanently impounded at destination customs. Nothing quite ruins a quarter like a multi-million-dollar parking lot, right? The one-size-fits-all approach is a complete myth here. Your supplier absolutely must provide documentation support tailored to your specific region, whether that's ADR compliance for Europe and Africa or DOT standards for North America. But going beyond just compliance, a true manufacturer offers deep customization. Take, for example, dividing a 45,000-liter tank into 5 custom internal compartments. This kind of engineering feat allows a single truck to simultaneously transport 92-octane, 95-octane, and diesel in one trip, completely eliminating the risk of cross-contamination. That level of customization just maximizes your daily operational efficiency.
Finally, we reach Section 6, RFQs and procurement logistics.
For those bottom-of-funnel buyers ready to execute, the logistical details of how this asset actually gets from the factory floor to your local highway are critical. Let's look at a realistic production timeline. Most industrial manufacturers accept a minimum order quantity of just 1 unit, though you definitely see better freight economics at 2 to 5 units. From day 1 of order placement, a standard build is going to take about 25 days. If you require a custom chassis or specialized fuel dispenser pumps with flow meters, expect that to push out to about 40 days. And when it's time to ship via roll-on, roll-off vessels or break bulk, make sure your contract strictly mandates a thick wax coating over the entire vehicle. This is a vital protective measure to prevent aggressive saltwater corrosion during the weeks it spends out on the ocean.
So, the crucial point is how you initiate this entire process. When you send out your request for quote, please do not just ask for a price on a fuel truck. Use this 6-step checklist. Tell them the exact medium. Jet fuel requires totally different specs than diesel. Give them the effective volume, your chassis preference, the exact compartment breakdown, whether you need a gravity discharge or a pump-out system, and crucially, your operating environment. A truck built for smooth coastal highways will absolutely fail in high-temperature mountainous terrain. Providing these 6 specific data points ensures you get an accurate, professional engineering proposal back, not just some boilerplate sales pitch.
We have covered a lot of ground today. The metallurgy, the critical safety valves, the strict welding standards, and all the compliance nuances that define a true heavy-duty asset. It's a lot to consider, I know, but the high stakes of this industry demand nothing less. So, I want to leave you with this final provocative thought. Look at your upcoming fleet expansion. Is your current procurement strategy focused merely on the price tag, or are you truly evaluating the engineering reality below the surface? It's a question that will undoubtedly dictate the safety, efficiency, and profitability of your fleet for the next 20 years.